All right, okay, example 21. Example 21 says, show that y is equal to ax sine x plus bx cos y is a particular solution of the differential equation d2y by dx squared plus y is equal to sine x. Hence, solve the differential equation d2y by dx squared plus y is equal to sine x, given that x is 0, y is 0, given that when x is 0, y is 0, and dy by dx is equal to 0. All right, now to prove that y is equal to ax sine x plus bx cos x is a particular solution, we need to make the relevant substitution and see if we can find values for a and b. If we can get values, if substituting the different differentials into the equation and we get values for a and b, y is equal to ax sine x plus bx cos x would be a particular solution. So let's start. All right, so we want to show that it is a particular solution. So particular solution. We have y is equal to ax sine x plus bx cos x. All right, let's differentiate. We're going to get dy by dx is equal to, well, it's a product derivative. So it's leave the first, differentiate the second, plus leave the second, differentiate the first. Next, leave the first, which is what? Bx, differentiate the second. When you differentiate cos x, you get minus sine x, plus leave the second, differentiate the first. Now, d2y by dx squared. Again, differentiating ax cos x. This would be minus, all right, so it's a product. So again, leave the first, differentiate the second. Plus differentiate the first, leave the second. Differentiate sine, you're going to get cos. Here we have minus bx sine x, which is a product. Leave the first. So minus, leave the first. Differentiate the second. Plus differentiate the first. Leave the second. Differentiating b cos x, you get b minus b sine x. Let's see if we can simplify this in any way, if it can be simplified. I don't think we have any more term in that. Ax cos x here. All right, so we can simplify this as what? Minus ax sine x plus 2a cos x minus bx cos x minus b sine x minus b sine x. Further simplify to ax sine x plus 2a cos x minus bx cos x minus 2b sine x. All right, so our differential equation to solve is d2y by dx squared plus y is equal to sine x. So let's substitute in our derivatives. So therefore, we would get minus ax sine x plus 2a cos x minus bx cos x minus 2b sine x. This is d2y by dx squared plus y, which is ax sine x plus bx cos x is equal to sine x. All right, so let's see what we can find. All right, so this goes and this goes. This and this goes. So now we have 2a cos x minus 2b sine x is equal to sine x. So this means that 2a would be equal to 0, and this is the cos x coefficient. And so a would be equal to 0. And what else? Minus 2b would be equal to sine x. And so, sorry, minus 2b would be equal to 1, which is the sine x coefficient. And so b is equal to minus a half. So b is equal to minus a half. It means that y is equal to minus a half x cos x would be my particular integral. All right, the next thing I think we're asked to do is that we're asked to solve the differential equation. So let's solve. We have d2y by dx squared plus y is equal to sine x. Let's get the complementary function, CF. To get the CF, we have to solve d2y by dx squared plus y is equal to 0. The auxiliary quadratic equation, we have m squared plus 1 is equal to 0. So m squared is equal to minus 1. M would be equal to positive or negative the square root of minus 1. So m would be equal to 0, positive or negative I. Therefore, the auxiliary, the complementary function would be y is equal to e to the 0x, open bracket, a cos x plus b sine x. So the overall solution would be y is equal to a cos x plus b sine x plus the complementary function, which is, I think, minus a half x cos x. But we were given additional information so that we can find a and b. We are told that when x is 0, when x is 0, y is 0, and dy by dx is also equal to 0. So let's see what we can find using when y is 0 and x, when x is 0, y is 0. We have 0 is equal to a, the cosine of 0, plus b, the sine of 0, minus a half times 0, the cosine of 0. The cosine of 0 is 1, so we have 0 is equal to a. The sine of 0 is 0, so that goes, and 0 times something is still 0. So here we end up with what? A is equal to 0. So now I can write that y is equal to b sine x minus a half x cos x. And I basically eliminated a cos x because a is 0. So let's differentiate dy by dx. Differentiate sine and get cos. So this is b cos x minus a half x cos x. It's a product. So let's take out the minus a half. Let's differentiate. Leave the first. Differentiate the second. Plus differentiate the first. Leave the second. Let's put in 0 for dy by dx and 0 for x. We have 0 is equal to b, the cosine of 0, minus a half times minus 0 times the sine of 0 plus the cosine of 0. Well, the sine of 0 is 0, cosine of 0 is 1, so we have 0 is equal to b minus a half. In the bracket, all we have is 1, so it's a half times 1. And so what we have is that b is equal to a half. So our particular solution would be y is equal to a half sine x minus a half x cosine x. All right, example 22. Example 22 says, find the general solution of the differential equation d2x by dt squared plus 4 dx by dt plus 3x is equal to 2 cos 2t plus 3 sine 2t, and show that for large positive values of t, x is approximately equal to 0.5 root 5 sine 2t minus alpha, where tan alpha is equal to 2. All right, so let's start. We want to solve the differential equation d2x by dt squared plus 4 dx by dt. So this is a non-homogeneous second order differential equation. 3x is equal to 2 cos 2t plus 3 sine 2t. All right, so the next thing is let us solve the homogeneous component of it. So let's get the complementary function, which is the solution of by dt squared plus 4 dx by dt plus 3x is equal to 0. All right, to solve this, we need first the auxiliary quadratic equation, which is m squared plus 4m plus 3 is equal to 0. Let us factorize. We have m here, m, 3, 1, everybody plus is equal to 0. So m plus 1 is equal to 0, or m plus 2 is equal to 0. M is therefore equal to minus 1, or m is equal to minus 2. So x is equal to a e to the minus t plus b e to the minus 2t is the complementary function. Let's get the particular integral. All right, for the particular integral, it is of the same form as f of x. So y would be equal to a cos 2t plus b sine 2t. Let's differentiate dy by dx. Differentiate cos, you're going to get minus sine. So this is minus 2a sine 2t. All right, let's be consistent. Using, it's not x we're using. It's not y we're using, it's x and t. So the particular integral, we have x is equal to, now dx by dt. All right, so over to the right, differentiate sine and get cos. So this is plus what? 2b cos 2t. Differentiate again. d2x by dt squared. We get minus 4a cos 2t minus 4b sine 2t. So substituting into d2x by dt squared plus 4 dx by dt plus 3x is equal to 2x, 2 cos 2t plus 3 sine 2t, and we are going to get minus 4a cos 2t minus 4b sine 2t, then plus 4, open bracket, minus 2a sine 2t plus 2b cos 2t, and then plus 3 times x, which is a cos 2t plus b sine 2t, and this is equal to 2 cos 2t plus 3 sine 2t. So let's simplify. So now we have minus 4a cos 2t plus 3a cos 2t. So that takes care of this and this. We have minus 4b sine 2t plus 3b sine 2t. That takes care of that and that. So now minus 8a sine 2t plus 8b cos 2t, and this is equal to 2 cos 2t plus 3 sine 2t. further simplify and we get minus A cos 2t minus B sine 2t plus 3B sine 2t minus, let me make an error somewhere with a sign. All right, that covers that. Right. All right, yep. I know where, all right, so it's minus, so these four are taken care of. And then I say no, minus 8A sine 2t plus 8B cos 2t is equal to 2 cos 2t plus 3 sine 2t. So let's form some equations. We have minus A, the cos 2 coefficient, plus 8B is equal to 2, equation 1, and this is cos 2t coefficient. Then we have minus B minus 8A is equal to 3, equation 2, and this is the sine 2t coefficient. All right, so let's simplify simultaneous equation. Let us multiply equation 2 by 8, or let's go equation 1 by 8. So we have minus 8A plus 64B is equal to 16, equation 1 by 8. Then we have minus 8A minus B is equal to 3. That's equation 2. Let's subtract. If we subtract, we're going to get 65B is equal to 13. So B is equal to 13 over 65. Substitute this in equation 1, we get minus A plus 8 times B, which is 13 over 65 is equal to 2. So here we get 8 times 13 over 65 minus 2 is equal to A, and we get A is equal to minus 2/5. A is equal to minus 2/5. So now I'm able to write my general solution, which is y is equal to, sorry, not y, it's x is equal to A E to the minus t plus b e to the minus 3t minus 2 over 5 cos 2t plus 13 over 65, the sine of 2t. All right, what else are we told? We are told that we found that and we're asked, hence, show that for large possible positive values of t, so when t is large, when t is large, so for large positive values of t, so when t is large, let us say t is approaching infinity and t is positive, a becomes 1 over e raised to, let us say, infinity. So that is 0. When t is positive and large, when you divide by infinity, you're going to get 0. So if when t is large, you find that a and b would both be 0. And so x would be equal to minus a half minus, 2/5, the cosine of 2t plus 13 over 65 sine 2t. So let us say that this is equal to r sine 2t minus alpha. So this would be r sine 2t cos alpha minus cos 2t sine alpha. And so r cos 2t, r cos 2t, or just r, r cos 2t, or r sine alpha would be equal to minus 2 over 5, and r cos alpha would be equal to 13 over 65. So the tangent of alpha would be minus 2 over 5 times 65 over 13. All right. I think this goes into this 5 times. This cancels that. This is minus 2. All right, we were asked to show that tan alpha is equal to minus 2, so I've done that. Tan alpha is equal to minus 2. So now let's find r. Here's what we know. We know that r squared is equal to minus 2 over 5 square plus 13 over 65, which is 1/5. 1/5 square. So this is equal to 4 over 25 plus 1 over 25. So R square would be equal to 5 over 25. So R would be equal to the square root of 1/5. Which is equal to 1 over root 5. Multiply the numerator and the denominator by root 5. We're going to get root 5 over 5, or 0.2 root 5. And so when t is large, x would be equal to r, which is what? 0.2 root 5, the sine of 2t minus alpha, where the tangent of alpha is equal to minus 2.